Today's lesson we are going to be talking about inverse relations. So of course the first question is, what is an inverse relation? Two relations are inverses when the x values of the first one are the y values of the second, and the y values of the first are the x values of the second. In other words, x's and y's switch places. So let's make we'll simplify it. X and y switch places. So, let's see what we mean by that. This is about as basic as we can get. This is a relation. A relation is simply any pair of points. So 1 is paired with 0, 2 is paired with 1, 3 is paired with 0, and 4 is paired with 2. They want us to do a couple of things. First, we are going to find the inverse relation. In other words, I'm going to create a new table where the x's and the y's have swapped places. So new table. Now the labels for x and y stay the same. It's that the actual values switch. So instead of 1 then 0, it's now 0 then 1. Instead of 2 then 1, it's now 1 then 2. 3 then 0 switches to 0 then 3. 4 then 2 switches to 2 then 4. So that's what it means to find the inverse, is simply take your x's and your y's and switch their places. Next thing that the directions want us to do is graph the relation and its inverse on the same graph. We're going to graph both the original problem and its inverse together. Now, I want to keep them separate, so I'm going to do the original in red and then keep my inverse in blue. So I'm going to start, just to do a little review. We know we got x left and right, y is up and down, positive, negative, positive, negative. So I need to go 1 to the right, 0 up and down. 1 to the right, 0 up and down. 2 to the right, 1 up. 2 to the right, 1 up. 3 to the right, 0 up and down. 1, 2, 3 to the right, 0 up and down. And finally, 4 to the right, up 2. 1, 2, 3, 4 to the right, up 2. And so that I can kind of see a relationship going on here between what's going to be red and blue, I'm going to connect these. So I'm going to make it go up, then down, then up again. So I'm going to switch to blue because I'm switching to my inverse. 0 left and right, up 1. 0 left and right, up 1. 1 to the right, up 2. 1 to the right, up 2. 0 to the right, up 3. 0, up 3. And finally, 2 to the right, up 4. 2 to the right, up 4. And I'm going to connect these in the exact same order I graphed them. So I started and I went from here to there, to there, to there. So do you notice anything about these two pictures? Do they look like a mirror image? Because they should. If you did this correctly, there should be a mirror or a reflection going on here. And I'm going to draw in the imaginary line that the reflection actually is. It is, and I'm going to draw a dash just so you can kind of see the difference. It's a dashed line. Whoa, let's make that a little thinner. Sorry. It's a dashed line that goes straight through. There we go. Let's try one last time. Straight through the center of the graph. Like if I was to connect the very top corner and the very bottom corner of the graph, that's your imaginary line. If you look, these two mirror. They mirror the entire time. That's not a coincidence. anytime you graph a relation and its inverse, there will always be a mirror image over this line. And this line, by the way, its equation is y equals x. It's where x and y are the same. And because we're switching x and y, that's why it's using that line as a mirror. So you're going to have some problems like this to work on with raw data, graph the data, flip it around, graph the other one. But most of the time when we're finding inverses, we're finding them with equations. So let's take a look at what a majority of our work is going to be doing. So we are going to be finding inverses of equations. So the first step is, in the equation, actually switch x and y. Now there's a little note to go here. You will see this little f of x notation. Ooh, that was a bad color. You will see f of x in your equation. If you ever see f of x, get rid of him first, make him a y, then switch x and y. Then solve the equation that you now have for y again. And there is a little note here, if you are using a square root, you want to remember a plus and a minus sign. So we're going to start out simple. We're going to start off with as easy as we can and then work up to harder questions. So here's our first equation. Y equals 3x plus 1. So according to our instructions, the first thing we do is we take the x and the y and we flip them around. So this equation now looks like, instead of y, it's x equals, instead of 3x, it's 3y plus 1. That's all there is to finding the inverse. Take the x and the y and switch their places. The reason we even do the second step, solve the new equation for y, the only reason we even do that step is for graphing purposes. So we are going to now get y by itself. So I want this letter to end up by itself. So what do I have to do? If it's helpful, let's put up our fins. I want to move this 1. I'm going to subtract 1 because that's the opposite. I can't combine these, so I'm just going to write it as x minus 1 equals 3y. Well, is y by itself? No, we're getting there. We need to get rid of the 3. So I'm going to divide by 3 on both sides. Now, y is by itself, which is what we wanted. Now I'm going to accept one of two answers. The first answer I will accept is what you have sitting here, x minus 1 divided by 3. So that's one option. And if you like y to come first, there you go. The problem is, if I asked you to graph this, that's not a helpful form for graphing. So if I want you to graph it, it would be easier to split it up. It would be easier to divide both of these by 3 separately. So the other option would be y equals, this is a 1, so 1/3 x minus 1/3. So if I ask you to graph it, that's going to be your easier method for graphing, to split it up. But I will take either one of these answers. So that really wasn't that hard of a problem. Let's make it just a little more difficult. Find the inverse of y equals x squared plus 4. First step, x has changed to y's, y has changed to x's. So instead of y equals, it's x equals y squared plus 4. So same rule applies. We want this guy by himself. Put up our fins. What's the first number we have to move? Well, that would be the 4. I'm going to subtract 4 from both sides. Can't do anything here, so I'm just going to write it as x minus 4 equals y squared. So that's the part that shouldn't be too bad. here's the problem. We need to get rid of a square. Well, what's the opposite of squaring? Hopefully you're thinking to yourself, well, it's square rooting, because we've done this before. So we're going to square root both sides, and those are going to cancel. So we have y by itself. There is nothing to simplify here. Leave it as the square root of x minus 4. However, one of our helpful hints said, if you use a square root, remember the plus or minus. And again, if you like y to come first, it's just y equals plus or minus square root of x minus 4. And no, this one does not have another answer. That is the only answer I will accept. Okay? So can we make it a little harder? Because those two have been pretty easy. More stuff, more numbers. Let's break it down. First problem is this right here. That's not helpful to us. So our very first note was if you see f of x, it's the same thing as y. So this equation is really y equals x minus 1 squared plus 5. But we haven't done the inverse yet. That was just getting rid of that ugly notation. Now we want to switch the x's and y's. So x equals parentheses y minus 1 close parentheses squared plus 5. Now, put your line up the middle. I want this guy by himself. So I'm going to start peeling away the layers. What's the furthest number? Well, that's the 5. So I'm going to subtract 5. This, I'm just going to write as x minus 5 equals parentheses y minus 1 squared. Now the common mistake here is that students want to move the 1. The problem is the 1 is inside of the parentheses. So what's outside of the parentheses? Because that's really what needs to go next. And that's the square. We need to get rid of this guy. Well, the opposite of a square is a square root on both sides. And those cancel. The parentheses will now go away because the squared is gone. On this side, we just keep it the square root of x minus 5, but what are we missing? That's right, the plus or minus. And then finally, here's the difference. Y is not by itself. We need to get rid of this 1. So we're going to add 1 to both sides so that we have y by itself. Don't combine the 1 with the 5. It doesn't work like that. We're going to just simply put it at the front. 1 plus or minus the square root of x minus 5. So if you like y first, it would be y equals 1 plus or minus the square root of x minus 5. Now I want to talk about something else related to this particular problem. When we see this notation, there's actually a special notation for that that means inverse. And it's this. F to the power of negative 1 with the x. Now we don't say to the power. We call this f inverse of x. That notation means the inverse. So I could write this equation as f inverse of x equals 1 plus or minus the square root of x minus 5. Yes, this is important. Yes, you might see it in your homework and in your test, so I want you to be familiar with that notation. So let's try one last example. at Oxbow. So let's look at this last example. Again, there's that notation. So we're going to make it y equals the square root of x minus 7. But we still need to switch x and y. So x equals the square root of y minus 7. Put up my line. I want this guy by itself. Well, I can't move the 7 yet. That's what we would normally want to do, but I can't. Why? Because it's under the square root. So we need to get rid of that square root first. Well, the opposite of a square root is a square. So I'm going to square this side and square that side. And again, those will cancel. That leaves me with x squared, because I can't do anything else there, equals y minus 7. Now that the square root is gone, yes, we can get rid of the 7. So now how do I move the 7? I add 7 to both sides. That gives me y by itself. Do not add those together. Just leave it as x squared plus 7. So if you like y first, it will be y equals x squared plus 7. But using our new notation, we could also say that f inverse of x equals x squared plus 7. And that's the end of the lesson.